So we need to find the rate of the angular momentum of the wheel, and then we have the torque of the on the wheel, and then the power generated. So we have the radius of the wheel 3.0 meters, and then we have v sub 1 equaling 7.0 meters per second, v sub 2 equaling 3.8 meters per second. We know that mass divided by t, so the amount of water going through the wheel every second, 85 kilograms per second. So for part A, we can say that the change in the angular momentum of the wheel will equal the change in the angular momentum of the water. So this will be equal to delta L initial of the water, and then this will be minus delta L final of the water. And this can be equal to mv1r minus mv2r, given that omega equals vr. So rather, given that the angular momentum equals I omega. So at this point, we can say that delta L of the wheel divided by delta t would be equal to m delta t times r times v sub 1 minus v sub 2. So we can say that this is going to be equal to 85 kilograms per second. So that'll be m divided by delta t, and then times the radius of 3, and then times 7 minus 3.8. And this is giving us a change in angular momentum per unit time of 816. And the unit would be kilograms per meter second per kilogram meter squared per second squared. Again, for the unit for angular momentum is kilogram per kilogram meter squared per second, and then dividing it by second again would give us a second squared as a denominator. So this would be our answer for part A. And then for part B, we're asking for the torque on the wheel, and this will be equal to delta L on the wheel divided by delta t. So this would simply be equal to 816 kilogram meters squared per second squared. And if you were to analyze the units, this is actually 816 Newton meters. So when we're trying to find the change of the angular momentum per unit time, we're actually finding the torque already. And then for part C is really easy because power simply equals the torque times omega. In this case, omega would be 2 pi over t. So we can say that it would be 2 pi times the torque over t. So this will be 2 pi times the torque of 816, and then divided by the period of 5.5 seconds. And we're getting a power exerted of 932 watts. So this would be your answer for part C, part B, and part A. That is the end of the solution. Thank you for watching.